Hello, welcome to PCAP's Native Prairie Speaker Series. My name is Caitlin Rose Seiler, and I am the Stewardship Coordinator with Saskatchewan Prairie Conservation Action Plan, or PCAP. Today, Tory Hartley-Cox will be speaking about great horned owls, a human-tolerant species thriving in an altered grassland environment. I'd like to start by stating we respectfully acknowledge that we are on the traditional territories of many Indigenous nations and communities, past and present. For millennia, they have worked to protect these landscapes and the life these areas sustain. I would like to thank these original caretakers and acknowledge the ongoing work and presence of Indigenous peoples in Canada today. Before we get going, I'd like to note that PCAP's Native Prairie Speaker Series is a monthly presentation about anything to do with Native Prairie conservation or species at risk. Stay tuned about upcoming webinars for this fall, and you can register for our Native Prairie Speaker Series webinars on the PCAP website, and all past webinar presentations can be found on the PCAP YouTube channel, and this webinar will be uploaded there in the near future. A reminder to our listeners out there, if you have any questions during the presentation, feel free to type it into the questions section of the webinar dashboard at any time during the presentation, and questions will be answered at the end of the webinar. I'd like to take a moment to note that financial support for today's webinar is provided by our presenting sponsors: Canadian Forage and Grasslands Association, Eco-Friendly West, Enbridge, Information Services Corporation, Saskatchewan Cattlemen's Association, SaskTel, and Wildlife Habitat Canada. In-kind support has been provided by Environment and Climate Change Canada. Special today, I am pleased to bring a few words from our sponsor, Eco-Friendly West. So Eco-Friendly West, formerly Eco-Friendly Sask, is pleased to have sponsored PCAP's Native Prairie Speaker Series webinars for the past 4 years. The SK-PCAP partnership plays an invaluable role in guiding conservation and management efforts within Saskatchewan's prairie ecozone, and we are pleased to be of assistance in making information easily accessible in order to promote healthy native prairie ecosystems and protect species at risk. Eco-Friendly West is a personal initiative of brother and sister Andrew and Penny McKinley. We use words and images to share our love of nature and our strong desire to protect the natural environment and all its inhabitants. Our online publication informs and encourages initiatives that support Western Canada's natural environment. That was from Eco-Friendly West. So without further ado, I'm pleased to introduce our speaker. Victoria, or Tory, Hartley-Cox is a graduate student at the University of Regina, co-supervised by Dr. Ryan Fisher with the Royal Saskatchewan Museum and Dr. Chris Summers with the University of Regina. Tory has her undergraduate degree from the University of Prince Edward Island in wildlife conservation. Before starting her Master's of Science, Tory had worked as a field technician in avian research and endangered species conservation since 2016, including work done in Australia, Florida, and burrowing owls in Alberta. Her MSc research is on the habitat selection, hunting behavior, and diet of the great horned owl in northern grasslands. So with that, I'm pleased to pass it over to you, Tory.
Hello, everyone. Thank you for joining me today on my presentation on great horned owls. So to give you some background information on the owls themselves, the great horned owl is North America's largest owl. They are between 3 and 4 pounds and can stand up to 25 inches tall. They have They have a wingspan of 4 feet to 4 feet 6 inches, and the females are larger and heavier than the males. Their iconic ear tufts or horns that they get their name from are not ears and are not associated with hearing at all, but are most likely used in visual communication between individuals. So the great horned owl is a silent and deadly killer. Their talons are zygodactyl, which means they have 2 toes in the front and 2 toes in the back, which they use to be able to grip onto their prey. Each talon is capable of exerting 750 psi of pressure, which is about the equivalent of 6 times stronger than the average man's grip strength. And the force needed to open these talons once they are closed is about 29 pounds of force, or what would be equivalent to a German Shepherd's bite. So once they grasp onto their prey, they are not letting go. So the second secret weapon that the great horned owl has is their nearly silent flight. So the great horned owl has serrated leading edges on their primary feathers, a velvety soft texture, and a tapered trailing edge that breaks up air turbulence and reduces the sound they make in flight, which allows them to sneak up onto their prey. So great horned owls are sit and wait ambush predators. They are a heavy bird that, compared to their wingspan, so it does not allow them to have the quick agilic flight as such as northern harriers or falcons would have. So they need to be able to wait out their prey, where they will, from a high elevated position, spot their prey and swoop in for the silent kill. So great horned owls rely more on their superior eyesight, where many owl species rely on their superior hearing. So the great horned owl has the largest range of any owl in the Americas. They occur everywhere from the south of the northern tree line down to the tip of South America, and inhabit every habitat from old growth forests to most deserts. So why is the great horned owl so adaptable? So broken down to its basics, great horned owls only really have 4 main requirements for habitat. The first we touched on is that they need perches for hunting. They need to be able to go up high and scan their surroundings for them to silently pounce upon their prey. They also need an abundance of prey. So these are large, hefty birds that require a lot of calories in order to sustain themselves. They also provide a lot of parental care to their nestlings, and even into post-fledging. They will take care of their young well beyond the point that most other birds have left them to fend for themselves. It's not only that they need abundant prey, they need this prey to be accessible to them. So great horned owls like to hunt in areas where there is open ground, where they can visually see their prey and safely swoop in without having to maneuver a lot in the air. So they like to hunt in roadsides, ditches, along the edges of meadows and fields, and in people's backyards. The next requirement they need is availability of nests. So great horned owls do not build their own nests, but they steal nests from other birds. So most likely other raptors, such as Swainson's hawks or red-tailed hawks, but they have been known to steal from large magpie and squirrel nests that they squish down to make a platform. So great horned owls do not migrate. They stay all year round, so they are able to start nesting really early as late February into March, even here in Saskatchewan, where it is still very cold in February. So the sight of a female owl on her nest covered in snow is not an uncommon sight. The females will lay between 1 and 5 plain white looking eggs, although 2 to 3 is most common. So you may have noticed that when I showed the range map at first, that there are these 2 large distinct areas vacant of great horned owls in South America. So based on what we had just learned about the great horned owl, we'll discuss why these areas are not suitable for the owls. So the first area up here is the Amazon rainforest. So this area has more than enough abundance of prey and endless possibilities for perches. These are very dense tropical forests, but what it lacks is accessibility of prey. So the great horned owls, as we know, are very heavy, not agile birds, and they're unable to catch prey in these dense forests. The next location are the Atacama and Patagonian deserts. So these sandwich the Andes Mountains range, and they are very dry, arid locations they do sustain large rodent populations in these areas. So it's not a lack of food that prevents owls from inhabiting these regions, but a lack of woody vegetation for perches and nesting habitat. So as you can see, great horned owls inhabit the entirety of the province of Saskatchewan, although they would have been historically in low numbers in the Prairie region of the province. So the southwestern northern reaches of the North American Great Plains would have had great horned owls, but they would have been limited to more the traditional zones of the grasslands and these natural riparian zones along rivers and creeks where some woody vegetation would have took place. So great horned owls did not really become common in the prairies until the 1940s. So the historic changes that resulted in the increased population of great horned owls in this region can be broken up into 3 distinct waves of significant environmental change since European settlement. The first would be that hunting and trapping removed large mammals such as the plains bison and the plains grizzly bear. The second is that large areas of prairies were leased for cattle grazing, which further altered the grassland environment due to key differences in grazing patterns and intensities between domestic cattle and bison. The third is that large areas of land was converted for agriculture, which also brought with it people who built barns and their homesteads, planted shelter belts and trees, which provided ideal habitat for great horned owls. So the great horned owls, although land conversion for agriculture has significantly decreased in the last several decades, the population of great horned owls continues to increase in the prairie region of Canada. So as we can see from this map, the blue represents a great increase transitioning to red, which is a decline. So the southwestern part of the province up until the 2000s is seeing significant increase in birds. So if the initial changes that resulted in more birds entering the prairies have significantly slowed, what are the modern causes to this increased population? So first off, we're going to look at where this data comes from. So it's based mostly off the North American Breeding Bird Survey, which is a long-term, large-scale avian monitoring program that was started in the 1960s. So this looks at overall trends of birds in a standardized route system. And so we can pretty accurately see that these owls are increasing in this region. So the modern changes that contribute to this is the continuation of fire suppression in these prairie regions, which result in an increase in woody vegetation, such as trees and shrubs, both natural from expansion from these low-lying areas and riparian zones, as well as the expansion of planted shelter belts and abandoned homesteads. There is also the increased building of anthropogenic structures, such as power lines, fence posts, and buildings, most notably the building of more modern structures, which often results in the abandonment of older barns and homes that great horned owls love to inhabit. So why is the great horned owl increasing significantly in population when other raptor species that also utilize these human structures for hunting are not benefiting nearly as much or at all? So one of the reasons is that the great horned owl is considered a synanthrope. So synanthrope comes from Greek and it means together with man. So a synanthropic species is a plant or animal that benefits from an association with humans and the alterations to the ecosystem that we cause. So other notable examples on the Canadian prairies are the pigeon, which would not have naturally occurred in the prairies at all, and then species like raccoon or common raven, which would have been in the more traditional or transitional locations of the prairies, but not the prairie proper, and then coyotes that were always in the prairies but have significantly benefited from the introduced food sources to humans and have proven to be quite tolerant of humans. So why are great horned owls interesting to study? In big part because they are one of the few animals that are adapting to the human landscape. So especially in the prairies, many species are in the decline while great horned owls are increasing. They are also a predator species, so it gives a unique opportunity to be able to look at what prey is available in these areas that there are great horned owls based on looking at what the owls are eating. So my project, I'm looking at habitat selection, hunting behavior, and diet within the Canadian prairies, most specifically the shortgrass prairie. So my project is three bases. I'm asking where are the owls nesting and what factors make these locations suitable? Where are owls hunting and what are they eating? And what types of human structures do the owls use when hunting? So my main focus for my study area is the southwestern corner of the province, which is often referred to as the South of Divide Conservation Management Area. So this includes everything from the east block of grasslands along the Montana border to the Alberta border, and then north of Shaunavon and Mankota. And this is where I do most of my field work. So the first part of my project is looking at diet. So to do so, I have set up trail cameras at nests and collect pellets. So why look at diet at all? So great horned owls will eat almost anything under a certain size, and I mean anything. They'll eat rabbits, ducks, even geese, your domestic cat if it's small enough, other owls, small rodents, amphibians, anything they can get their talons on. And so you can learn a lot about what prey species are in a given area based on what the owls are eating, because owls will eat most things based on how abundant they are. So they do not discriminate. If they see it, they eat it. So this is an image I got from one of my trail cameras. And as you can see, this poor tiger salamander did not stand a chance. So this is a new species added to the list of what we know great horned owls will prey on. So that's pretty interesting, poor little guy. This is another notable thing I've had. So this one nest, it was one single nest, had 9 birds in it at one given time. So it had 2 coots, 1 shoveler, 2 green-winged teals, 1 widgeon, and 2 pipe-billed grebes. And this was piled in one single nest. The nest had 3 nestlings in it, although I only thought there was 1 at one point because the other 2 were piled up with ducks and I couldn't see them. And then, so this would have been the cumulative effort of both the male and female, because both will hunt for their nestlings. Probably over the span of only 2 days, these birds had not started to smell or rot, so it was more of a recent kill. So this is a great example of just how efficient these birds are at catching their prey. So the second part of my project is looking at perch points or hunting locations. And to do so, I captured 10 owls, 3 females, 7 males, using modified mist nets. So for those who don't know, mist nets are these fine mesh nets that are in panels that create little pockets that are suspended between 2 poles. They're typically used for songbirds, but will often be used for smaller owl species, such as northern saw-whets. They are not designed for large, heavy birds, such as great horned owls, so I modified them by adding rubber bands to the ends of them and suspending them to the poles with the bands. This allows the owl to hit the net and decelerate more gradually, allowing it to fall into the pocket of the net without destroying the net or injuring the bird. So in order to catch a territorial male, the best method I found to do this would be to take 2 mist gnats and place them in a V formation with a decoy owl in the center playing a territorial hoot call. I would try to place a perch that I thought the territorial male would use between the V formation and have at least 1 or 2 other perches on either side of the net that the territorial male would likely go to. The idea being that the male will either fly between 2 perches and get trapped in the net, or the male will attack the decoy owl, getting trapped in the narrow V part of the net setup and fly into the net. So once I actually capture an owl, I need to attach the satellite transmitters to them. So these transmitters are, they use an onboard battery instead of solar. We went with this method because great horned owls are nocturnal, and we were afraid that they would spend all day in a barn somewhere or under a tree canopy, and it would not allow for the transmitters to charge. So we have an onboard battery system that makes the transmitters a bit larger, but as we know, great horned owls are quite large, and so this is no issue for them. The information is stored on board and downloaded via Wi-Fi to a receiver. We chose this method rather than having the data automatically downloaded through cell service because a lot of the areas in my study area are not within cell. But the downside to this method is that you need to find the bird in order to get within range to download the data. So we attached VHF transmitters to our satellite transmitters, which you can see at the bottom on the image. It is the small gray transmitter with the antenna sticking out so that we can manually locate birds to download data. So the transmitters fit on the birds kind of like a cross between a backpack and a bra. So the transmitter itself goes on the very back of the bird between the wings and sits nicely on their back with 2 straps going up over the shoulders and 2 coming around the belly where they attach on the keel. So the transmitters are made of Teflon ribbons so the owls cannot chew them off, but they are sewn on with dental floss so that the dental floss will eventually break apart and the transmitter will fall off the bird eventually. So this is the interface used to program the transmitters. These transmitters are quite interesting in that you can reprogram them anytime you want, almost. You just need to be able to connect to it. So you can change your programming later on while it's already on the bird. So these are the live feed. This is where you'll see in real time the information that is being picked up by your transmitter, where this field is kind of a summary location. It'll tell you how many points the transmitter currently has on it, your downloading process, the battery life, and other key information that you may want in the field. So this is the field where you actually program your transmitter. So I have my transmitter set to take points every 5 minutes. And this is where you can record extra information. So I have where it records what speed the bird was going when the point was taken. So I have it set up like this. So I know if the bird is sitting and waiting and perching, most likely hunting, or if the bird is moving, it is likely just moving between locations and not hunting. So this mission start delay would be a way to program the transmitter to wait before it takes its first points. The idea being if you handling the bird or whatever animal you're working with alters their behavior. So we go with 0, so we don't have any delay because we found that the great horned owls are very tolerant of being handled and will often go straight back to whatever they were doing before you arrived. So females will often go straight back to their nest and sit like nothing happened. And this is the field where you can record how long the GPS searches for a satellite when you which works really well when the owls are in a building. If they're not within range to connect with a satellite, this will wait up to 90 minutes to look for a satellite. And this is where you program how long you want the transmitters to work. So my transmitters are programmed to start working an hour before sunset, and they shut off an hour after sunrise to get the hunting duration of the owls. So this is what the information gets when you first get them from the transmitters. This is kind of a summary program that allows you to look at it. So this is the summary sheet. This is kind of a breakup of all the transmitters that are on your computer, and it gives you key information like the distance the bird has traveled, the number of recorded points, the battery life of the transmitter. And once you click on an individual bird, you will get a rough map of where these birds are actually going. So the black points are the actual locations, and the pink lines are the estimated direct route between points that the bird would have taken. So this field at the bottom is more of a detailed of the individual bird. As you can see, I had to test the program of this transmitter. I had set it to take 1 point an hour initially before programming it for my standard 5 minutes. And so you can see where it gives you the information and ramps up what information it's giving you based on how frequently you ask it to give you information. So more detail. So I want to give you an example of kind of the territory use we're seeing so far with these owls. So these are two of the females I caught. The one on the right is a female in more of a grassland habitat. So she's in a small day use area park within native grassland. So she takes long, frequent trips away from her nest. She has gone as far as 3 kilometers away from her nest, presumably for hunting purposes, where the female on the right is a female within a small shelter belt within cropland, and she rarely leaves her nest very far. She has not gone even 1 kilometer away from her nest, and she uses the same hunting routes over and over again. So she doesn't get very far, where the female in native prairie travels quite far. So that's kind of the interesting look we're getting at, how they use different habitats differently. So to take a slightly closer look at the first female in the more grassland habitat, I am getting thousands upon thousands of points for each bird. So we need to break it up in a way that I can look at more fine scale data of locations. So to select perches, I overlay 100 meter by 100 meter grid onto the use area for this individual bird. Each cell will be ranked by how often she uses it, whether she uses a lot, a little, or not at all. And within each of these use areas, perches were selected at random. So here's a closer look at the 5 most used areas she has. So the red arrow is pointing at her nest. And you can see that she really uses the trees and buildings that surround her nest. So for perch sites, I am first and foremost looking at what habitat type they are in. So I kept this fairly broad, but is the perch in native prairie, cropland? Is it at someone's occupied or unoccupied home? And for each perch, I am looking at the vegetation around it. So I am using a Dummermeyer frame to get the general ground cover and a Rubel pole to get density. So I am looking at this because, as we had discussed before, the gray horned owl really needs open, accessible areas to catch their prey. So ground cover and density is very important to the owl's ability to feed themselves. For each perch, I am also determining what kind of perch it is, whether it's a tree or a building or such, and measuring how high it is to see if the owls are selecting for certain heights of trees or certain heights of buildings. I am then keeping track of the number and types of anthropogenic structures within these birds' high use territorial areas to see if they're selecting more for natural perches versus human created perches. So the third part of my project, I am looking at nesting. So this is kind of broken up into two parts. There's my direct field observations and then a citizen science component. But basically I am asking two simple questions. Where are the nests and what habitat are the nests located in? So the image at the bottom of the screen is all the nests I found through field observations. And this is mainly within that south of the divide area. And I've found over 80 nests in this region. So for the citizen science component of my project, I have two ways people can communicate with me. There is an easy to fill out survey for the general public to submit their owl observations, which you can find at the Royal Saskatchewan Museum webpage. And then people can contact me directly through email at uofrowlresearch@gmail.com. So I've been very fortunate so far to have an amazing turnout of wonderful people submitting their observations throughout this year. So I've had 570 participants in the survey so far, which is crazy. Never expected this much turnout. So I thank anyone who had submitted their observations. I've also had many wonderful people contact me through email, providing locations for nests, their observations of owls, questions they may have, and I encourage people to contact me through that email anytime. So for the citizen science observations, I will be combining the provided locations from the public with GIS information layers such as land cover type, land use, tall structures like the power line systems, in an effort to better understand nest site selection. So this map is a generalized area of where I'm getting citizen science reports from. So each square is 25 by 25 kilometers. And so as you can see, I have quite a few people submitting in Saskatchewan and quite a few people along Highway 1 and Calgary and Edmonton in Alberta. So I am very thankful for all this coverage that the citizen science allows for this project. So what do I hope to learn? So I really want to understand the habitat use and diet of the great horned owl, especially seen as they are a synanthropic species that is increasing, and what management applications that could have for their prey species, especially species at risk and other game species. This gives an unique opportunity to study a relatively new predator to a region and how that affects its environment. And you can get secondhand information about their prey abundance and distribution within the different habitats of my study area. So what do I hope to accomplish? I really would like to provide a provincial scale map of great horned owl nest use and provide a smaller scale map of where predation by great horned owls are on the landscape the highest, as well as what features are associated with the higher rates of predation risk by great horned owls. So thank you for listening to my talk. And I encourage anyone to contact me through the email if they have observations or questions. So does anyone have any questions? Thank you.
First of all, thank you so much for the great presentation. I learned a lot. Like, who knew they didn't have ears? I guess it makes sense. I just always assumed. I guess I should say that those feathers there aren't their ears. That's what I always imagined. But we do have a couple questions coming in. The first one is, how does flash photography affect great horned owls?
Yeah, so that's a good question. So they have extremely sensitive eyes. Their night vision is really acute. So I would recommend refraining from using flash photography if possible. I know it's tempting because they're beautiful birds and you want to get images of them, but it would be quite unpleasant for them to have that flash of a bulb in their eyes.
Absolutely. What is the impact of avian flu on great horned owls?
Yes, so that is definitely something that I've been very cautious about this year. So avian flu can and does affect great horned owls. There have been quite a lot of reports of great horned owls dying, especially in the southern US, although there are reports here in Canada as well. So during my project, I took extra steps. I would disinfect my boots between every site. Any equipment that possibly could have touched, anywhere that an owl could have touched, constantly disinfected. I never went between sites directly without disinfecting and washing my gloves and everything. So they are quite they can be heavily impacted by avian flu. They are a non-discriminatory feeder, so they often go after ducks and other birds that are heavily affected by avian flu. So
Makes sense. It's unfortunate. How long will juvenile owls remain in the area after they fledge?
Yeah, so good question. So there is some depending, often they'll stay until the fall though. So they fledge typically around June, but they will remain with their parents up until probably October into November.
Okay, interesting. We have a few questions about their prey. So the first one is, do you have any evidence of species at risk in their prey, specifically greater sage grouse?
Yes, so great horned owls are fully capable of taking on larger prey. So the larger size of the sage grouse would not be an issue for, especially a female great horned owl. We know they take sharp-tailed grouse all the time. I've found multiple sharp-tailed grouse in their nest this season. And yes, there's also footage of great horned owls taking ferruginous hawk nestlings right out of the nest. So they are potentially a risk to species at risk. So yeah.
Wow, that's really interesting. What is the most common prey species that you've seen in their nests?
So this differs between nests, but most commonly they're bringing small rodent species like deer mice. I have individual owls that seem to really take a lot of ground squirrels or gophers. But so it'll really depend on what habitat they're in. But small rodents make up a good percentage of their diet.
Okay, interesting. You talked about the 9 ducks in one nest, and do owls often have a big buffet for their owlets?
So this differs, I believe, also by their habitat. So if they have an abundant source ready to go, they will stockpile food for their offspring. It's not uncommon for me to go up to a nest and find 2 or 3 prey items waiting for the nestlings, especially when they're smaller and eating less. That particular case was the nest was not too far from a pond, and it was during duck migration. So these owls took full advantage of the fact that there was abundant ducks in this small pond.
Yeah, it sounds like it. That's pretty interesting. Yeah, we have a couple questions sort of about just their habitat in general. Can you comment on the amount of use that you've seen in old buildings and what times of year this would be occurring?
Yes, so they love old buildings. They will spend as much time in those old buildings as they can get. So and they will use them all year round. They use them to get out of the elements. They use them as perches for hunting. Quite often they'll even use them as nest sites themselves. And quite often small rodents like deer mice are attracted to these sites as well. So it's a win-win-win for the owls. So they absolutely love old abandoned barns and houses.
Makes sense. Another listener is wondering about in that homestead with the nest location, the owls seem to avoid some trees that were very close to the nest. In the square just below the nest location. Do you know why? Is it related to the tree species, the size or age, or closer to the human house?
Yeah, so I think it was just those were particularly very large trees. And so the lowest branch to the ground was still probably like 3 meters up. So the owls just don't have as well of a vantage point to see. It's almost too high. So they prefer kind of medium-sized trees where they can still see a large area while also being close enough that they don't have as far to travel to catch their prey.
Okay, interesting. And another listener is wondering how long will a pair of great horned owls remain in the same area? And he says, I used to see them regularly, but the past couple of years, he's not seen one single owl. Do you have any comments about that?
Yeah, so a pair of owls, if it's prime territory, will remain there for as long as there's nesting habitat available to them. So an area might be well for owls and might have successfully had owls in the past, but if there's no available nest for them to take, then they may not stay there. So if no other environmental conditions have changed in your yard, but you notice that the Swainson's hawk nest that the owls used to occupy is now broken and no hawks have moved back in to rebuild it, then the owls won't return until there is a nest available for them.
Okay, that makes sense. That's all the questions for the moment. When you and I were talking earlier, you mentioned you wanted to put on your webcam to show a stuffed owl. Is that right?
Yes, I have an example to show kind of the size of the owls. So numbers are hard to picture for everyone. So I have this trusty owl here to kind of give you a general sense of like the size of these owls. So this would be a female owl. So she's a bit larger than the males would be. So her wingspan, if she were to be alive and open her wings directly, for me, would probably come to about my neck to the ground. And she, yeah, and I don't know if you can see it, but their talons are pretty big.
Yeah,
So,
wow.
yeah, something I am quite familiar with, having had a talon handshake with one of the females. She put her talons straight through my gloves that were normally used for ferruginous hawks. So they're quite sharp.
Yeah.
So yeah, so this gives a better sense of the size you can expect with these very large birds.
Yeah. Wow. So tell us about this this owl handshake.
Oh yeah, so the females are larger and more feisty than the males. So the males, once you put a hood on them, they tend to just clock out. They just go limp and let you do what you need to do. The females will fight you the entire time. They will wait for any opportunity to bite you, and they will wait for any time to grab a hold of you. So it was between a transfer of birds. My assistant that day was not as experienced, and they're heavy birds, right? So her arm was tired. So I went to grab the bird, had started to struggle, and she grabbed onto my glove and went right through. I was fine. It just like embedded in my palm a bit, you know?
Yeah. Did it break the skin?
Oh yeah, we had to like pry it out.
Oh man. So do you need to get like a tetanus shot or anything, or just a little bit of polysporin
Yeah,
and you're good?
yeah, they're a very small entry wound, so you just really clean it out and everything
Yeah.
and keep an eye on it. Yeah, otherwise she was a good girl, the owl. Her transmitter on went with no issues. I mean, you're not working with birds of prey unless you got a few scars, right?
Yeah, yeah, that's the way to look at it. A couple more questions have come in here. The first one is, have you seen any direct evidence of an owl hunting on a grouse lack, either a sharp tail or sage?
Not directly. a lot of the areas where these leks are not the most accessible. So they're hard to monitor, as well as a lot of these areas are not actually prime habitat for great horned owls. So a lot of the sage grouse leks are in true prairie. So that kind of gives them a buffer that sometimes saves them from the prying eyes of great horned owls.
And what is the largest home range size that you've encountered by a pair of owls?
So I don't quite have that data yet. The transmitters are still on the birds. So the maps that I had been showing in this presentation are only a few weeks worth of data. So the transmitters have been on the birds for a couple months now, and I'm actually heading out in the next 2 days to go download the next round of data. So it'll be interesting to see if these territories are larger than they first appeared, just based on the few weeks of data that I have available right now.
Yeah, that would be really neat to see. We'll have to have you come back when you finished your your research. Yeah, and the last question that we've got here is, how do they use their ear tufts for communication? Has it ever been studied?
I think mostly it's just like observational studies. So people that have rehab birds or observe them in the wild. I'm not aware of any dedicated study to that behavior, but they will put them up or put them back or move them in ways towards each other. So quite often the female will put her ear tufts down when she goes to snuggle her nestlings. I catch on camera, which is pretty cute. And they will put their ear tufts up when the male and the female reconnect, and they'll do like a courtship call to each other. So they definitely use them in communication. We just don't quite understand the nuances of it.
Interesting. Oh, that's really neat. Cool. Do you know how people could get involved as a citizen scientist? Like, do you have opportunities available for them?
Yes, so there's always the survey you can submit where you can put when you find nests or just your owl observations in general. We're going to be having that left open all the way until next year. So encourage anytime through the winter or the breeding season. Also, I monitor that email. So you can always contact me through my the project email with any questions you have, any observations. There's also plenty of opportunity for landowners to get involved. I always am looking for nests to put cameras up at or owls to capture and put my transmitters, and I love when landowners are very involved with that. I encourage them to come out with me and catch the owls with me as well. So I had quite a few landowners get to actually hold their own owls, which always put a lot of smile on people's faces, as well as getting to see their nestlings as I put the cameras up and stuff.
That's really neat. That's a really neat experience for anybody. We've had a couple more questions come in here. Will great horned owls reproduce every year?
They're capable of it, but they don't. So sometimes they will just take a year off. I don't blame them. I'd want a break too, but sometimes not sure why. I had one pair of owls that I was watching, hoping they would nest. They had plenty of available nests to them. They had beautiful location, and they just didn't. And sometimes their nests fail early on and they don't try again.
Okay. So, you just know. One listener here commented that there's live baiting being used for photography, and he says, I've heard that great horned owls, if they see a prey like a mouse, they have to catch it, like they must catch it, and that's why it's being used as like live baiting for photography. Have you ever heard anything about that? I know it's kind of outside the scope of your work.
Yeah, I've definitely heard of people doing that. I'm not a fan of baiting any animal, either with bait or calls or anything for photography purposes. So these owls, although they won't always go for available prey, they will, and it just increases the likelihood of them getting injured. You're taking away time that they would otherwise be spent actually hunting and being able to feed themselves and their nestlings. So I would stray away from using those methods for photography. I don't even necessarily like doing it for research purposes. It's kind of a necessary evil for my work.
Yeah, yeah. Have you seen them, like, do they have to catch live prey, or will they let live prey go if it doesn't seem to meet their needs or it puts them at risk?
So one of the methods we had tried early on is a beltatry trap, which is essentially you put live bait into a cage that you put into another cage that has like these little fishing line nooses in order for the owl to land on it and get caught. So that only ever worked once. Most other times the owls are immediately suspicious that something is up and they won't go for it. So there is circumstances where they'll see prey and they won't go for it. Just like us, like if you're not hungry, if you have a nest full of 9 ducks already, you may not go for it, you know?
Yeah, yeah, that makes sense. And then a comment has come in from a listener named Joel, and I think Joel did a webinar for us a couple of years ago about sage grouse. And the comment is, we have seen both great horned and snowy owls killing sage grouse around Lex in Alberta. So that's interesting. Do you have any comments about that at all, or if you've seen anything similar?
Yeah, so I put special care into looking in these areas, especially in grasslands. And this year, fortunately, we haven't had any owls near the grouse in this area. So luckily, it's not the issue they're having this year. So
Yeah, yeah, for sure, for sure. And what was your original interest with great horned owls? How did you get involved with this sort of research?
So I've mostly worked with endangered species before, and I've worked with burrowing owls just last year. So I've always had a soft spot for owls, and after years of working with an endangered species, it was kind of an interesting flip to look at a species that is on the increase. I've never worked with a species that could even remotely be called common, so it's kind of an interesting perspective looking on the other side of things.
Yeah, yeah, for sure. That's kind of all the questions and comments that we have right now. But there's been a few people that have written in and say, thank you so much. It was very interesting. And I want to reiterate their comments there. This was a really awesome presentation. I think the first one we've ever had about great horned owls. So thank you for coming and sharing your wealth of knowledge with us, your research, and just your passion. It's great to see your enthusiasm. So thank you.
Yes, thank you for having me do this talk. It was great. Thank you.
To all of our listeners out there, you'll be able to catch the recording on our YouTube channel in the near future. And then, Tory, when will you expect your results to be wrapped up?
So this is the first year of my study. I am actually still doing fieldwork. There's transmitters on birds right now that I'm going to go check on just the end of this week. So I still have one more school year and then one more field season, and then I should be wrapping up next year.
Awesome. So next year, so we'll have to have you back then. Could you put the email address in the chat box? Maybe there's some inquiries about how people can contact you about owls.
Yes. Yes, I can do that as soon as I figure out how to do that. So it's U of R. Oh goodness, what is it? I never email myself. U of R owlresearch@gmail.com. So yeah,
in the chat box, U of R owlresearch@gmail.com.
Yes.
Perfect. So we've had a dozen more comments coming in to say that thank you. This was very interesting, awesome presentation. So I guess we'll leave it at that for the day. And thank you again, Tory. And we look forward to having you back when your research is wrapped up.
Okay, thank you.
Awesome.
Yep, and I encourage anyone to contact me through email with any questions you have at any time. I never get enough of talking about owls, so.
That sounds great. Well, thanks everyone for catching our webinar, and we hope to catch you on the next one. Have a great rest of your day.
Bye.
Bye.